Alright, so today we're going to be talking about limits, and in specific, we're going to be talking about polynomial limits. Okay, so polynomials and limits. So in the last video, we saw some properties of limits and how we can split limits that are being added or subtracted together, multiplied or divided, and we can also deal with exponents. And we're going to use those properties as well as the two limits that we are familiar with. If you remember, that's the limit of a constant and the limit of y equals x. Okay, so let's just jump into it and solve our first limit. So we have the limit as x approaches 2 of this polynomial function x to the exponent 3 minus 2x plus 7. Okay, and what we know with limits is that we can separate them into addition and subtraction. So let's go ahead and do that. We can do that here, and this will become the limit as x approaches 2 of x to the exponent 3 minus the limit as x approaches 2 of 2x plus the limit as x approaches 2 of 7. So far we haven't done anything crazy. We've just used our properties of limits to separate this into 3 different limits, and we're allowed to do that. Okay, and continuing with this, we're going to continue using those properties to simplify this even more. So we have an exponent here. And remember, if we have an exponent within a limit, we can actually take it out of the limit. So this is going to be the limit as x approaches 2 of just x, and then we're going to take this whole limit and raise it to the power of 3. So we're allowed to do that. Over here we have multiplication. We have a 2 multiplied by an x, and again, if you remember, we can separate limits of two things being multiplied. So the limit as x approaches 2 of 2 multiplied by the limit as x approaches 2 of x. And we'll put all of that just in big brackets as well, so we don't forget to include the negative sign on it. And then finally, this last limit, well, that's simplified as much as we can simplify it, so we're just going to leave that as it is. Okay, wonderful. And from here, we actually know all of these limits. So we know what the limit of y equals x is, and we know what the limit of a constant is. Okay, so we're familiar with all of these limits, and therefore we can now solve this answer. Or sorry, solve this question. So the limit as x approaches 2 of the function x, if you remember correctly, that is just equal to whatever number x is approaching, in this case 2. So that's going to be 2, and that's raised to the exponent 3, minus, okay, we have the limit as x approaches 2 of a constant, and that's always just going to be the constant, times the limit as x approaches 2 of x again, and that's just whatever number x is approaching, so that's 2 again, and then plus the limit as x approaches 2 of a constant. Remember, that's just going to be the constant, in this case 7. And now if we simplify this, 2 to the exponent 3 is 8. 8 minus 2 times 2, which is 4, so 8 minus 4 is 4, and then 4 plus 7, we get 11. Okay, so we've now successfully solved this polynomial limit. Okay, and we've done it by using the properties of limits and the two limits that we are familiar with. Okay, so we can get away with solving a lot of limits without actually having to, do too much work. It's just going to be a little bit of simplification. So that was our first example. Let's move on to our second example. Okay, so our second example is going to be the limit as x approaches -1 of, again, some polynomial function, 2x to the exponent 4 minus 3x. Okay, and again, how are we going to start this? Well, first we're going to split it up into addition and subtraction. So we have the limit as x approaches -1 of 2x to the exponent 4 minus the limit as x approaches -1 of 3x. And then from here, we're going to further simplify. So this first limit, we can see we still have multiplication and we have an exponent. So first we'll deal with the multiplication, then we'll deal with the exponent. Okay, so dealing with the multiplication, this is going to become the limit as x approaches -1 of 2 multiplied by the limit as x approaches -1 of x to the exponent 4. Okay, minus, and again, here we have multiplication, so this is the limit as x approaches -1 of 3 multiplied by the limit as x approaches -1 of x. And again, we'll put that in brackets just so that we don't forget to distribute that negative sign. Okay, and now finally, we have a limit here. We can't simplify this first one anymore, but the second one, we still have an exponent, so we need to simplify that exponent. So this first one we'll leave as it is. This is the limit as x approaches -1 of 2 multiplied by the limit as x approaches -1 of x, and then just this limit, because remember the exponent is just applied to the x. It's not applied to the 2, it's just applied to the x. Therefore, we're going to have an exponent here. Okay? And if we want to just be safe, we can put this all in big brackets. Not necessary, but just for clarity's sake. And then the rest of these limits we can just rewrite because there's no more simplification to do with them. Times the limit as x approaches -1 of x. Alright, so now we've used our properties of limits to simplify this as much as we can. So let's go ahead and solve. The limit of a constant is just that constant, 2, multiplied by the limit of x is whatever x is approaching. So x is approaching -1 in this case, so this is -1. And don't forget the exponent 4, minus limit of a constant is just equal to the constant, and limit of x is just equal to whatever x is approaching, again in this case -1. And what do we get? Well, we're going to get 2 times -1 to the exponent 4. -1 to the exponent 4 is just going to be +1. So we're going to get 2 times 1, which is 2. And then we're going to get 3 times -1, which is -3. Then we have minus -3, which is +3. So 2 plus 3, and that's just equal to 5. Okay? Wonderful. That's our second polynomial limit kind of dealt with. Now, instead of doing multiple of these examples, because as you're kind of starting to see, this isn't really too difficult. We follow the same process. Separate the addition and subtraction, separate the multiplication and division. Well, there's not going to be any division in polynomials, but separate out the multiplication, and then separate out the exponents. You should be good to go then, and you can get your answer. There is a bit of a trick to solving polynomial limits, however, and that trick is saying that basically for any polynomial, okay, so now we're just talking about in general any polynomial, including the 2 that we did, but for any polynomial you can think of, let's call that polynomial p of x. Okay, we're saying that for any polynomial that exists, the limit as x approaches some number a for that polynomial is going to equal that polynomial evaluated at whatever number x is approaching. Okay, so x is approaching a, we're evaluating our polynomial at a. Okay, so this is the kind of rule that saves us from having to do all of this extra work. Okay, so let's see if this rule is bogus or if it's actually a good law or a good rule to follow. So let's go back to our first example up here, okay, where we were talking about limits. And on the side here, we'll kind of just do like a quick check, a double check, or a sanity check. Okay, so what is our polynomial p of x? Our polynomial p of x is just x to the exponent 3 minus 2x plus 7. Okay, what is our polynomial evaluated at a? Remember, a is whatever number x is approaching. In this case, x is approaching 2. So our polynomial evaluated at 2 is going to be 2 to the exponent 3 minus 2 times 2 plus 7. Okay? And what do we get with this? Well, 2 to the exponent 3 is 8. 8 minus 2 times 2 is 4 plus 7. A minus 4 is 4. 4 plus 7 is 11. And what do you know? We get the same answer of 11. And what you'll actually notice is that when we do this substitution of p of 2, okay, where we substitute in the a value, in this case 2, we get 2 to the exponent 3 minus 2 times 2 plus 7. And if you look down here, right after we have separated out our limits and we solve our limits, as in we solve this limit as x approaches 2 of x, the limit as x approaches 2 of 2, the limit as x approaches 2 of x, and the limit as x approaches 2 of 7. When we solve those limits, we get the exact same expression, 2 to the exponent 3 minus 2 times 2 plus 7. And that's not a coincidence. Of course, they should be the exact same because you should be getting the exact same answer. Okay? So it works for our first one. It's going to work for our second one, but let's just, again, do a sanity check, make sure that we're not going crazy here. So p of x, what is p of x equal to in this case? It's equal to 2x to the exponent 4 minus 3x. Okay, and p of a, this time instead of evaluating our polynomial at 2, we're evaluating at -1. Okay, so -1. Now we just substitute -1 wherever there's an x, minus 3 times -1. And we ask ourselves, okay, what do we get here? -1 to the exponent 4 is just 1. 2 times 1 is 2. Then we have 3 times -1, which is -3, minus -3 is just plus 3. 2 plus 3, and that's equal to 5. And again, what you'll notice here is that you get here 2 times -1 to the exponent 4 minus 3 times -1. That is the exact same expression that you're going to have here right after you're done solving your limits. Okay, and again, that's not something that happens per chance. It's something that happens because that is what this rule is saying that's going to happen. So very useful thing to know. So from now on, whenever we get some sort of a polynomial, we can just substitute in the value that x is approaching for that limit. In this case, it was -1. In the previous example, it was 2. Okay, we can substitute that value into the polynomial and just solve the polynomial, and we'll have our answer. Okay, that's everything for polynomials. Coming up in the next video, we're going to ask ourselves, well, that's great, we know how to solve polynomials now, but what happens when we get something that's not a polynomial? There's a lot of equations out there, a lot of functions out there that aren't polynomials. How are we going to deal with them? What's going to be our tactics with that? Okay, so that's coming up in the next video.